So hello everyone, today we are going to discuss the general organic chemistry. Okay, so in the first lecture we will discuss the hydrocarbon. Okay, hydrocarbon. Okay, so if you see the name of hydrocarbon, so it is made up of carbon and hydrogen. Okay, so main component in organic chemistry is carbon. Okay, so carbon, there are several properties of carbon like catenation. Okay, so the meaning of catenation, that it forms a series, means a length of chain of hydrocarbons like that. Okay, so we will not represent this one, we will represent the its open form. Okay, so it formed like that. Okay, so due to catenation properties, it formed the self linkage. Okay, and it is due to tetravalency. Okay, it is due to its tetravalency. Okay, means carbon having valency of carbon is 4. Okay, so if you see this structure, okay, so this is carbon. Okay, how much hydrogen is attached? 3 hydrogen, so you will attach 3 hydrogen. Okay, 3 hydrogen is attached in this side, and this bond is also attached, means the ion of the carbon is also attached this one. So carbon have attached from 4 atoms. Okay, like that. So it okay, so it is the meaning, it's having due to tetravalency. Due to a tetravalency, it form its chain like structure. Suppose that this carbon having 4 valency, next carbon having, it also having form 4 bonds. Okay, so like that. Okay, so if you see this one, this means this bond will form attached with hydrogen, this 2 hydrogen. Okay, so like that. You will also open this one, so 2 hydrogen you will attach, then it will fulfill the 4 valency. Okay, and terminal is 3. Okay, so if you see here, carbon form 4 bonds. Okay, so it is the meaning of that sentence. Okay, so it is due to tetravalency, means carbon having tetravalency. Okay, so that's why it formed like that. Okay, the next part is, it is a small size. Okay, it have a small size, it have a small size means carbon having, actually it form 3 types of bond. The single bond, this is single bond, it is called single bond. Okay, next it form double bond. Okay, it form double bond, carbon having how much valency? 4, so 2 will be also attached. Okay, so it form double bond. Okay, and it also form triple bond. Okay, so 3 types of bond, due to having a small size, it having 3 types of bond: single, double and triple bond. Okay, so it form the triple bond. Okay, so it forms 3 types of bond, and if you see, these 2 type of bond is called pi bond, and it form the sigma bond. Okay, so we will discuss the what is sigma and what is pi, like that. Okay, so here we will only discuss the properties of carbon only. Okay, so next part, if you see here, okay, so due to small size, it form the carbon double bond, triple bond and single bond. Okay, next is its bond energy is very high. Bond energy is very high. Okay, very high. Okay, so how you can calculate, if you break this bond? Okay, so single, this one. Okay, so this bond energy will be very high. Okay, so it is the meaning of this sentence. Okay, next one is, if you see here, okay, so we will discuss here sigma bond and pi bond. Okay, so what is sigma bond, what is pi bond? Okay, so we will take one example here. If you see this one, like that. Okay, you can also attach 3 bond. Okay, and this one. Okay, so if you see here, this carbon. Okay, so first of all, you will fulfill the, I have discussed that carbon having how much valency? 4 valency. Okay, so you will first, you will attach how much bond? You will attach 4 bond from carbon, so we will attach 4. Okay, 3 1 3 is this one, 1 is this, means 4 bond. Okay, 2 3 you will attach one hydrogen only. Okay, one this one, 2 3 4 this one. Okay, so 3 and okay, so here 3 4 3 4 means it is fulfilling. Okay, so if you see here, these are hydrogens. Okay, so if you see here, this is the sigma from where it comes, means carbon. If you will see this type of structure, means carbon is attached from hydrogen always. Okay, so these are the sigma bond. In this only one sigma bond and one pi bond. Okay, in this triple bond, one two, how much sigma and how much pi? 2 pi and one sigma bond. Okay, one sigma bond. Okay, and this is also sigma. So how much sigma and pi bond? So 3 sigma is there, 1 sigma is there, 3 4 5 6 7 8 and 9. Okay, so means 9 sigma. How much pi? 3 pi. Okay, 3 pi bond. So total 9 sigma and 3 pi bond is present in this molecule. Okay, so it is the simple way to recognize sigma and pi bond. Means sigma is always, means if single bond is present, it is always sigma bond. Okay, and if double bond is present, then one sigma and one sigma, one pi. If triple bond is present, then how much? 2 pi and one sigma. Okay, so it is the uh, basic recognition of sigma and pi bond. Okay, so it is uh, so I think you will calculate the sigma and pi bond. Okay, so next one is actually this question is asked in IIT in 1989. Okay, in, so it is the question which will be asked in IIT 1989. Okay, so next one we will discuss, what we will discuss next, suppose that we will discuss the hybridization. It is very important point, hybridization. Okay, so hybridization means there are three types of hybridization. First, sp3, sp2 and sp. Okay, sp3 means in this sp hybridization, how much sigma bond is present? Sp 4 sigma. Okay, sp2, how much sigma? 3 sigma is present. Okay, and in this 2 sigma is present, 2 sigma is present, means what we, if you see here, in this the geometry of sp3 will be tetrahedral, geometry of sp2 will be trigonal planar, and sp it is always linear. Okay, so bond angle, if you see in sp3, 109 into 5. Okay, so it is the angle in sp3 hybridized carbon. Sp2 hybridized carbon having bond angle 120 and 180 is present in the sp hybridization. Okay, so it is the simple hybridization which is present in the different hybridized carbon. Okay, it may be sp3, either sp2 or sp. Okay, so here we will take how you can recognize it is sp3, sp2 and sp. Suppose that this is the methane structure. Okay, so carbon having valency 4. So first of all you will attach 4 carbon. Okay, so between two atom, the bond between two atom is called its bond angle. Okay, so it is sigma bond, it is all sigma bond, so it is bond angle will be this one, 109 to 5 degree. Okay, so it is the bond angle between two atom. Okay, and geometry will be tetrahedral. Okay, so it is the simple means a bond angle. This is sp3 hybridized, sp3 hybridized, bond angle 109 to 5 degree, and geometry will be tetrahedral. Okay, so next we will take example here, sp2 hybridized carbon. So if you see sp2 hybridized carbon, so sp2 hybridized sp2. Okay, so in the, okay, so it is the simple three types of carbon is sp3, sp2 and sp. Okay, bond angle is 109, 5 degree, 120 degree and 180 degree. Okay, next one is geometry is tetrahedral, trigonal and planar. Okay, sp3, sp2, sp carbon. Okay, so it is the hybridization. Next we will see the, suppose that the one question arises here, sp this carbon is sp2 because double bond is present. Okay, so if you see here the bond angle between two atoms, okay, so it's between this one, this is hydrogen, this is hydrogen, okay, it is also hydrogen, okay, okay. So this one is 120, okay, in which carbon, this is the carbon is this carbon is sp to hybridize bond, okay, sp2, and geometry will be trigonal planar, okay. So it is the simple recognition, and in case of sp2 hybridize, this is the carbon is sp hybridize, okay, this one bond angle will be how much, 180, geometry will be linear, okay, linear, okay. So it is the simple recognition of hybridization in different type of carbon, okay. So three types of hybridization means three types of carbon is present, either they will be sp3, sp2, or sp, okay. Bond angle will be 109 to 5 degree, 120 degree, and 180 degree, okay, respectively, means sp3, sp2, and sp, okay. And geometry will be tetrahedral, trigonal, planar, and linear, okay. So it is all about the hybridization, okay. The question we will next we will discuss some questions in which you will solve the which type of bond is present, okay. So simple example we will take here, this is cn, this is cs, this is cs2, okay. So the question is that which type of which type of bond is present in this molecule, okay. So in this is the triple bond, okay, triple bond having 2 pi 1 sigma, in this 1 sigma and 1 pi, okay. So first of all, okay, so how much sigma and pi, so after mentioning these pi bonds, you then you will open the this structure, okay. So this will like this one, this is hydrogen is attached this one like this, okay, and these are the hydrogens, okay. So how much pi bond, how much pi bond, 2 pi and 3 pi, means 3 pi is present, okay. 1 sigma is there, 1 sigma is there, 2 sigma, 3 sigma, 4 sigma, 5 sigma, and 6 sigma, and 6 sigma, okay. So question, there will be four option, one in which like a b c d, okay, a b c and d, and in which different means different answer will be given in like 2 pi and 5 pi like that, okay. So the question in which 3 pi 6 like that, okay, and 1 2 pi 1 pi, okay. So one option will be the correct in the given questions, so the correct option will be like the 3 pi and 6 sigma, okay. So this type of question will be you can see in the IITs and medical exams, okay. So next question we will see here, cs2 double bond ch single bond ch cs2, okay. So if you see how much sigma and pi, the question will be asked here. First of all, hybridization sigma and pi bond, sigma bond and pi bond, okay, like that, okay. So which hybridization is present in this molecule and how much sigma and pi bond is present, okay. So this, so if you see here, this carbon, when carbon is attached from double bond, it will be sp2. This carbon is also attached to double bond, then it is always sp2. This is carbon is attached double bond, then sp2 it will also, so only one type of hybridization is present, sp2, okay. Sigma and pi, if you calculate here, this guy, if you see here sigma pi 1 sigma, this first of all you will calculate pi bond, 1 pi and 1 pi means 2 pi, and sigma bond 2 sigma is this one, okay, because if you open this structure, this carbon you will attach 2 carbon which is attached from single bond, 2 sigma, okay, 2 sigma, 3 sigma, 4 sigma, and 5 sigma, okay. This one 6 sigma, 7 sigma, 8 9 means 9 sigma and 2 pi bond is present, and hybridization will be the sp2, okay. So question can be asked like that, this molecule having sp3 hybridize and having 2 pi and 9 sigma, okay, like that, and three option will be wrong, so first option will be the correct one, okay. So so it is very means this type of question is very important, okay. The next one, if you see here, we will talk about the alkane we'll talk about the alkene, and when we will talk about the alkyne. So first of all, we will take here alkane. What is alkane? Okay, suppose that if you see here, the simple alkane is CS4. So carbon having, I have discussed, having 4 valencies. So first of all, you will attach 4 single bond. Okay, so once how much, so these are the sigma bond. Sigma means the compound which having sigma bond is called alkanes. Okay, so it is the simple alkane, and bond angle will be bond type only sigma bond present. Okay, बॉन्ड एंगल की बात करोगे, जब बॉन्ड एंगल की बात करोगे तो 109 इंटू 5 डिग्री. ओके, एंड जियोमेट्री की जब बात करोगे तो टेट्राहेड्रल, टेट्राहेड्रल. ओके, सो इट इज द सिंपल some characteristics of alkane. Okay, so if you, okay, so it is the main characteristics of alkane. Okay, so next we will discuss the alkene. We will take here alkene. Okay, we will take here alkene. Okay, so alkene, if you see here, the structure of alkene is means double bond will be present in the molecule. Simple molecule is C2H4. Okay, so means here is 4 carbon. So if you see here, only 4 carbon, only 4 hydrogen is here. Okay, 2 carbon which is attached will be attached from double bond. Okay, so double means 1 pi bond will be present in the alkene. Okay, and bond angle will be 120 degree. Okay, and geometry will be square planar. Okay, so and hybridization will be sp, double bond always having sp2. Okay, so here hybridization comes होगा sp2. Okay, so it is the characteristics of alkene. Okay, next we will talk about the alkyne. Alkyne means it, this one. Okay, so in alkyne, the simple alkyne is this one, acetylene. Okay, it is known as acetylene, and in this, if you see here, so this sigma, how much bond, which type of bond is present? Sigma in this 2 pi and 1 sigma. Okay, so next one is geometry. कौन सी होगी? So when we talk about the geometry will be linear. Okay, linear means bond angle कितना होगा? 180 bond angle. Okay, geometry we will discussed earlier, it is linear. Geometry linear. hybridization कौन सा होगा? hybridization कौन सा होगा? sp. Okay, so it is the some characteristics of alkane, alkene and alkyne. Okay, next part we will discuss here molecular formula. Okay, molecular formula. So what is molecular formula? Okay, so molecular formula, if you see, suppose that we will take example butane. Okay, so butane is represented by butane means how much carbon? 4. Okay, C4H10. Okay, so C4H10 is the molecular formula of butane. Okay, so if you, so first of all, if you draw the structure, you will draw the 4 carbon, because 4 carbon is here. Okay, and 10 hydrogen is there. Okay, so the carbon having 4 valency, 1 2 3 4, this carbon will be fulfilled by 4, 1 2 3 4, this carbon is will be fulfilled by 4. Okay, so if you count this hydrogen, this will be the 10 hydrogen. Okay, so these are the molecular formula, means a complex type of formula, and you can draw this type of structure. Okay, next we will, so molecular formula will be this one. This is the molecular formula of butane. Okay, next we will talk about the structural formula. So if you talk about the structural formula, what is the structural formula? There are 3 type of structural formula is represented. First one is structural First one is means structural formula represented by three form. Okay, first one is expanded. Okay, next one is condense. Okay, and third one is bond line. Okay, means any structural formula you can represent it via three types. Okay, expanded, suppose that we will take example of butane. Okay, so this I will take this example. Okay, so this is the expanded form. Okay, expanded means you can also say open form. Okay, open form. Okay, so next condense means it will be closed form. Okay, closed form means cs3 cs2. You can represent this formula like that. Okay, means cs3, this hydrogen is three hydrogen, so we will attach three hydrogen, means close, we will open to close form. Okay, cs2 cs2 cs3. Okay, like that. The next one is bond line. Bond line means like that, these point representing the carbon. So there are four carbon. So there are four carbon, 1 2 3 4. Okay, so four carbon we will draw this one. Okay, four carbon. Okay, and these are the carbon. Okay, and carbon having four valency, so you will attach here three hydrogen, so these are the hydrogen. Okay, so means what I am asked that it you can represent this form into this one. Okay, and 1 2 3 4 1 2 3 4. Okay, like that. Okay, and if you open this structure you will looking like that, these are the hydrogens because carbon having valency 2. This is the carbon. Okay, this is the carbon, this is the carbon, so it having, and it will attach from 3. Okay, so means you can represent this form into either this one or either this one. This is the expanded means open form, either you can represent this condensed form. Okay, or you can represent through this one. Okay, so it is the structural formula by you can represent it three types of structural formula. Okay, so it is the three ways by which you can represent the structure of the butane. Okay, so next we will talk about the, suppose one we will discuss some, we will take some example of bond line structure because it is very important. Suppose that this one, so how you can draw this structure. So actually this point is called carbon. Okay, so 1 2 3 4 5 6 carbon is there, so you can draw the 6 carbon 3. Okay, and carbon having valency 4, so these are the hydrogens, so you will attach 1 2 3 4, means fulfill, there will be 2 hydrogen. Okay, means you will fulfill the valency by hydrogens. Okay, okay, so it is the bond line structure. It is the which structure which is expanded structure, means you can see the open form, you can see the open form. Okay, closed form, this will be cs3, 3 hydrogens, so you can represent this one. So question will be asked which is the which is the condensed structure of butane. So it is the condensed structure of this one, 3 3 6. Okay, and it is the expanded structure. Okay, and it is the bond line structure. Okay, so in the question it will be asked which type of means bond line structure of butane will be. Okay, so you will be recognize and put the right answer. Okay, the next one is we will talk about the saturated and unsaturated. Okay, so what is saturated, what is unsaturated. Okay, so in if in the structure sigma bond is present, then it will called saturated. Okay, the first point is that. Okay, second point is that all sigma bond किसमें पाए जाएंगे, all alkanes. Okay, all alkanes having sigma bond, all alkanes. Okay, the next point is that suppose that so we will take here one example, C2S6. Okay, C2S6 means first of all you will draw the two carbon because two carbon is there, and you will attach six hydrogen. So these are the sigma bond, and this structure is called because sigma, only sigma bond is present, then it is saturated structure. Okay, so it is the simple characteristics of saturated molecules. Okay, unsaturated, in this one or more pi bond will present, one or more pi bond will present will present. Okay, so in unsaturated one or more pi bond will be present. Okay, the next one is all alkenes and alkynes are alkenes and alkynes, okay, are unsaturated. These are the unsaturated. Okay, means in which pi bond, these alkenes and alkynes only pi and sigma bond is present, but pi bond is present, so that's why it is unsaturated. Okay, the example we will take here, suppose that this is the ethylene. Okay, so if you see here, this carbon fulfilled by two hydrogens, and this is the double bonds, this is the this one, so this is called pi bond. Okay, so since pi bond is present, so it is called unsaturated. Okay, so it is the simple characteristics of saturated and unsaturated. Okay, so I think you will be understand what is saturated and what is unsaturated. Okay, so then the next example we will take here, we will discuss here degree of carbon. Okay, so the next part we will take here degree of carbon. Okay, degree of carbon. So first of all, you should be know that three type of degree: 1 degree, 2 degree, and 3 degree. Okay, so degree of carbon, if you talk about, suppose that we will draw this structure. Okay, and so it the degree of this carbon will be which degree? It will be the 1 degree, means carbon attached from which, means how much carbon from which this is attached, one carbon, so it is 1 degree. This carbon is attached from two carbon, then degree will be 2. This one 2, this one 1 degree, means the carbon attached from other carbon, how much carbon? That means I want to say that the degree is you can write down the degree of carbon. The degree of carbon can be explained by attachment of carbon, attachment of number of carbon, attachment of number of carbon atoms. Okay, so atoms. Okay, so if you see here, this carbon is attached from how much carbon? One carbon, so degree will be the 1. This carbon is attached from two carbon, so degree will be 2. This carbon is attached from two carbon, then degree will be 2. This carbon attached from one carbon, so degree will be 1. Okay, so it is the simple recognition how you can recognize the degree of carbon. Okay, the next the next example we will take here. So this if question will be asked that what is the this carbon having degree of carbon, then 2. This is the carbon attached from two carbon, so degree will be 2. Okay, so it is the simple like that you can also solve this one. So degree of this carbon will be how much? 3, because 3 carbon is attached from this carbon. Okay, so it is the simple structure, and here 4 degree of carbon is also seen. Suppose that this carbon, okay, so carbon, this carbon is attached from carbon having 4 valency, so maximum the carbon will attach from 4 hydrogen, 4 atoms. Okay, so this this carbon is attached from 4 carbon, so the degree of this carbon will be 4. Okay, so it is the simple explanation of degree of carbon. Okay, so in question will be asked that to which type of degree present in this molecule. Okay, so so question will be asked in the exam like that, CS3 CS2OH. Okay, so if the question is asked that this carbon having degree of carbon, then how you can explain this? First of all, you will see how much carbon is attached from this carbon. Okay, so only one carbon is attached from this carbon, then degree will be 1. Okay, you can also this is the primary carbon. Okay, okay, so it is the simple like that. If the question will be asked this one, that what is the degree of carbon of this molecule? Okay, this one. So this carbon having degree of carbon is 4, means it means this carbon is attached from 4 carbon, so degree will be 4. Okay, so the carbon having attached from another carbon is called their degree. Okay, so since 4 carbon is attached from this molecule, so degree will be the 4. Okay, the next part is that the next we will discuss the degree of hydrogen. Degree of hydrogen. Okay, so degree of hydrogen, how you can uh, recognize the degree of hydrogen. So if you see here, we will take one example here, cs3 cs2 cs3. Okay, so degree of hydrogen, suppose that this hydrogen. Okay, so you can easily recognize the means recognize, first of all, if you recognize the degree of carbon, so degree of carbon will be, this is 1 degree, that the similarly it will be the degree of hydrogen. Okay, means it the degree of hydrogen from this molecule, this hydrogen will be primary, this hydrogen will be, this carbon is attached from 2 carbon, so degree will be similar. Okay, so this will 2 degree. Okay, like that it will be 2 degree, it will be the 1 degree. Okay, so it is a simple techniques by which you can recognize the degree of hydrogens. Okay, next we will explain the degree of alcohols. Degree of alcohols. Okay, so how you can recognize the degree of alcohols. Okay, so if you see here, this one is alcohol, means OH will be attached from the molecule. Okay, so suppose that this one, so what is the degree of this molecule, degree of this molecule? Okay, so if you see the degree of alcohol, then degree of alcohol will be, this carbon is attached from how much carbon, 2, so degree will be 2, means it will be the secondary alcohol. How, which alcohol? Secondary alcohol. Okay, and if you see this example, cs3 cs2 cs2 OH. Okay, so this carbon is attached from 1 carbon, so degree will be 1 degree. Okay, and this hydrogen will be the 1 degree hydrogen. Okay, so it is the primary alcohol. You can also write down, this is primary alcohol, it will the secondary alcohol. Okay, and if you write this one. Okay, so in this so how you can recognize that which type of alcohol, then if you see here, this carbon is attached from 3 carbon. Okay, so it is tertiary alcohol. Okay, so if you recognize the degree of carbon, then you can easily recognize the degree of hydrogen and degree of alcohols. Okay, the next we will talk about the degree of amines. Okay, degree of amines. Okay, so degree of amines, how you can recognize the degree of amines? Suppose that we will take example here, cs3 cs2 cs2 nh2. Okay, so if you talk about the degree of this amine, okay, so simple, if nh2 is present, this, the first tricks is that if nh2 is present, then this is primary, always it is primary amine. If nh is present, then it always secondary, and if n is attached from this one, then it is tertiary. Okay, so it is the simple technique, but we will we explain through the degree of carbon. Okay, so by which you can also recognize this which type of amine, since carbon is attached from 1 carbon, so it is primary amine. Okay, simply if you see here, this one. Okay, so this one is secondary because carbon, this amine is attached from, if you see here, this is hydrogen. Okay, this is, okay, so it is, this nitrogen is attached from 2 carbon. Okay, this nitrogen is attached from one carbon, this nitrogen attached from two carbons, so degree will be 2 degree amine. Okay, simply if you see this one, CS3 CS3 CS3, this nitrogen is attached from 3 carbon. Okay, so degree will be 3 degree amine. Okay, or you can say the tertiary amine. Okay, so it is the simple techniques by which if you simply if you are able to recognize the degree of carbon, then you can recognize all the functional group. Okay, all the amines, alcohol and hydrogens. Okay, the next we will discuss here uh, classification of organic compounds. Okay, classification of organic compounds. Okay, classification means how much type of organic compound is present. Okay, and they can classify in series form. Okay, so if you see here organic compound, if you talk about the organic compound, then it is two types. Okay, two types means one is acyclic, and another is cyclic. Okay, so acyclic, what is the acyclic and what is cyclic? Okay, so acyclic means it will be always in open structure. This is the condensed structure, its open structure will be looking like that. This one, this is hydrogen. Okay, but cyclic means it will be the in cyclic form. So the three carbon is present, so you can represent this one. This is the bond line structure, but you can also represent this one. So because it is in cyclic form means one structure will be end up in this. Okay, so this is the cyclic, it is the acyclic. Okay, so it is a simple uh, way to learn this type of organic compounds. Okay, the next we will talk about the uh, okay, yes, one, suppose that this is this one. Okay, and if you write down this structure, so which is cyclic and which is acyclic, so this is, since it is start and end up in this position like that. Okay, so it is the closed or cyclic structure. Okay, and this is the open acyclic, means it is not in cyclic form. Okay, so simple this type of question can be asked. Okay, the next one is if you talk about the uh, organic compounds, so we will, so compounds can be classified into two form, one is acyclic and one is cyclic. Okay, the next one is acyclic is further divided into either they will be saturated or saturated or they will be unsaturated. Okay, so either they acyclic compound will be saturated or unsaturated. So saturated and unsaturated we will discuss earlier, and cyclic compound may be two types, either they will be alicyclic or aromatic. Okay, alicyclic or aromatic. Okay, so you can take the okay, so saturated means only single bond is present. Okay, means sigma bond is present. Unsaturated means one or more than two pi bond is present. Cyclic means alicyclic means they will further divided into homo and hetero. Okay, simply they may be aromatic is further divided into homo and hetero. Homo and hetero. Okay, so we will take here saturated, unsaturated we can explain here. Alicyclic, if you talk about the alicyclic, so homo means suppose that this one, homo means a similar type, so in this only carbon hydrogen is present. Hetero means if you attach one structure like that, so it is hetero alicyclic compound, this is homo alicyclic homo cyclic compound. Oh, sorry for that. If you talk about the cyclic, then it is two types, alicyclic or aromatic. Okay, alicyclic is further divided homo hetero, aromatic is always divided into homo and hetero. Okay, so alicyclic, if you talk about the CS3, first of all it will be cyclic. Okay, so this, suppose that this is the structure. Okay, so this you can also represent this one, CS2, this CS2, CS2. So if you talk about, if you see here only carbon hydrogen is present in this. Okay, But if you attach this one, if this one, okay, so first of all it is the cyclic form, but here nitrogen is present, uh, means one carbon is replaced by nitrogen. Okay, so carbon is present, hydrogen is present. If carbon hydrogen is present, then it is called homo, but here nitrogen is also present, then it is called hetero. Okay, but in case aromatic, homo means aromatic. Suppose that this is the simple structure of benzene. So benzene is aromatic, means benzene will be the cyclic structure and it will be aromatic. Aromatic means pi bond will be continuous, means alternate position. Okay, like that. This is double bond one, this is double bond alternate, single and double bond is present. So this is the single, this is the double. So this is homo because carbon hydrogen will be present. If you replace one carbon by one another atom like that nitrogen, okay, so it is the first, it is aromatic, but carbon is replaced by nitrogen, means here three types of atoms is present, so it is called hetero aromatic cyclic compound. Okay, so question will be asked that which compound is uh, first heteroaromatic cyclic compound, then the right answer will be this one. And the question, if question will be asked which compound is homo aromatic cyclic compound, then answer will be this one. Okay, so this is the simple classification of organic compound. You can click this way. Okay, so okay, so it is the simple classification of organic compounds. Okay, so I think you will learn from all types of organic compounds. Okay, the next part we will discuss here aromatic compounds. We will discuss aromatic compound. Okay, so aromatic compound. Okay, how you can explain which type of which compound is aromatic and non aromatic. Okay, so aromatic compound is further divided into two types. Okay, two types. One is benzenoid, which is benzenoid, and another is non-benzenoid. Another is non-benzenoid. Okay, so aero compound is two types: benzenoid and non-benzenoid. Okay, so benzenoid and non-benzenoid, as name, as from name, it representing only if in structure only benzene is present. Suppose that this is the benzene structure. Okay, so benzenoid compound only benzene ring will be present, and like that it is the all compounds are benzenoid because only a benzene ring is present. Okay, non-benzenoid, if you replace one carbon by like that. Okay, this one. Okay, this lone pair of electron of nitrogen involved in the aromatization. Okay, so this compound is called non-benzenoid because benzene ring is not present here. Okay, so simply you can explain this, the compound which having only benzene ring is called benzenoid, and in the compound which having uh, hetero atoms in the benzene ring, it is called non-benzenoid compound. Okay, the next point is that if you talk about the condition of aromatic, conditions of, means what is the condition by which any molecule is called aromatic or not. Okay, so condition of aromatic, condition of aromatic. Okay, so condition of aromatic, first it will be the cyclic, it will be the cyclic, means cyclic, then it will be cyclic. Cyclic means this one. Okay, so it is the cyclic. The second condition is that it will be the planar. Okay, so these are the structure in plane. Okay, this whole area is in plane form, so it will be in plane, so it is the planar structure. Planar means it will be sp2 hybridized. Okay, and it will always in conjugated system, it will always in conjugation. Okay, so conjugation होना चाहिए, cyclic होना चाहिए, planar होना चाहिए, sp2 hybridized होना चाहिए. Okay, the next one is it will follow the Hacker rule. Okay, Hacker rule. Hacker rule. What is the Hacker rule? It is the simple represent. It is a simple formula which represented means the Hacker. If the condition will be followed, this one, then it will be the aromatic. Okay. So 4n plus 2 pi electron. Okay, in the compound, if this rule will be followed, then compound will be the aromatic. Okay, so the next part is suppose that we will take here example of benzene. Okay, so this is the benzene. sp2 hybridized is present. This carbon is sp2. Cyclic is ring is cyclic. Okay, planar, in the plane it will be in plane. Okay, so sp2 hybridized cyclic है, planar है. The next one is 4n plus 2 pi electron है कि नहीं, it will. Okay, so if you see here, the total electron will be either 2 pi, 4 pi, 6 pi. Okay, not 4 pi, it will 6 pi, 2, 6, 10, 14. Okay, if the total pi electron will be this one, then it will follow the Hacker rule. So 4 n plus 2 pi electron. So here n number n, this n represent the how much carbon is attached. Okay, so how much carbon is attached? 6. Oh, sorry for that. Sorry, this n represent the ring. Okay, only ring. How much ring is present? One ring. Okay, so pi electron. Okay, sorry for that. One is I am forgetting that in this only a1 2 3 means 3 pi bond. So it will actually it will present the 3 pi bond. So pi will, this n represent the pi bond. Okay, so how much electron here? 14 electron. 14 electron means it follows the Hacker rule. Okay, so benzene will be the aromatic. Okay, so by which you can say this ring will be the aromatic. Okay, so it is the simple formula and some conditions by which any molecule is called aromatic. Okay, suppose that this one. Okay, so the question will be asked, this compound is aromatic or not. Okay, so if you see here, so first of all compound will be cyclic. साइक्लिक होना चाहिए, हाइब्रिडाइजन sp2 होना चाहिए. नेक्स्ट वन इज अल्टरनेट कॉन्जुगेटेड सिस्टम होना चाहिए, कॉन्जुगेटेड, और हाकर रूल को फॉलो कर, प्लेनर होना चाहिए और हाकर रूल को फॉलो करना चाहिए. ओके, सो इफ यू, so first of one by one we will see this structure, the rules is followed by this molecule or not. Okay, so first of all this is cyclic. Okay, cyclic, this one is cyclic, sp2, this one carbon is sp2. Conjugation means alternate single and double bond present है, planar, planar है. Hacker rule is 4n plus 2 pi. Okay, where n represent the pi bond, so 3 to 5 pi bond is present, so you can calculate the 5. Okay, so how much electron is present here? 2, 3 to 4. So 4 bond is 18 electron. Okay, so this is, since it represents the 18 pi electron, so by which it is follows the aromatic system. Okay, so this molecule will be the aromatic. Okay, so it is the simple some concept by which any molecule is called aromatic. Okay, so the next one is okay. Okay, so next we will talk about the first of all we will discuss the conjugated system. Okay, what is conjugated, what is annullines. Okay, so conjugation, if you see here, this, suppose that this one. Okay, and cumulines. First of all we will discuss the conjugated system. Suppose that this carbon is attached from single bond, and if you attach alternate single and double bond. Okay, so this is called, in this system is in conjugation. Okay, suppose that if you attach this single bond, then it is called non-conjugation. Okay, so it is the simple way of understanding how this means which which molecule is conjugation and which is non-conjugation. Okay, the next point we will discuss here, types of organic compounds. Okay, so three types of organic compounds, types of organic compound, three types of organic compound. One is spiro, one is bicyclo, the next one is bicyclo and bridge compounds. Okay, bridge. Okay, so spiro compounds, how you can explain this type of this compound is spiro or not? Okay, so if this one is looking like that, okay, means one, if one carbon is in between two ring, okay, means two ring attached by one carbon, then it is called spiro. Okay, bicyclo means if two ring is attached from two carbon, this is the two carbon here and this is the two ring. Okay, so it is bicyclo. Okay, and bridge compound, if one compound, within one compound, okay, within one compound, two carbon, if sorry for that, if more than two atoms shared by two rings, if more than two atoms shared by two rings, these are two ring, more than two atom is shared by two ring. Okay, so here more than two ring, two atoms may be like that. Okay, or this one. Okay, here one or two or three or four, like that. Okay, so if more than two atoms shared by two ring, it is called bridge compound. Okay, so this type of compound you also seen in the organic chemistry. Okay, so it is, okay, so it is the some representation of organic compounds. Okay, so types of organic compounds, they may be like that. Okay, okay, so okay, so next we will discuss the IPAC. Okay, so this lecture is about 1 hour. Okay, next lecture we will also discuss 1 hour, and third lecture will be 1 hour. Okay, in these lectures we will explain all the general organic chemistry. Okay, general organic chemistry. Okay, GOC. So you can learn in 3 lectures all the GOC. Okay, so please after watching this video, please subscribe these channels. Okay, subscribe and like channels. Okay, and we will meet again in the next lecture. So thank you for all. Okay, all the best.